Hey class, how's it going? For today's video lesson, I'm going to be talking about literal equations. Now, literal equations um, apply specifically to physics because what they are, they're normal equations with variables, but each variable means something important. So, a very famous equation, such as E equals mc squared, right? Everyone's ever heard of that equation, right? E equals mc squared. That's a famous equation derived by Einstein, right? So what it means by literal is that each letter in this equation has a meaning. So like E stands for energy. This means energy, right? Where M means mass, all right? And C means the speed of light. The speed of light. So C meaning the speed of light, M meaning mass, and E meaning energy, right? So that is a literal equation. Now, literal equations can be solved like any other equation, right? So for example, if I wanted to figure out what's an equation for C in this situation, now I can algebraically solve for C in this equation. I'll go through that step by step. So we want to get C by itself on one side. So to do that, I can divide M to both sides, right? This M cancels out with that M, all right? And then we're left with an equation that looks like this. C squared equals energy over mass. So the speed of light squared is equal to energy over mass. And then the next thing we can do to both sides of the equations to balance it out is then we can take this square root. So the opposite of c squared is the square root of that value. So then you have the square root like that. And then our final equation is going to look something like this. C equals the square root of energy over mass. All right. Now that is the same thing you would do in any math class. That's just typical algebra. Nothing is different. All right. This is an example of a literal equation. Okay, so we're going to do one more example. All right. So in a very common equation that we use in physics, especially in the first unit is called 1D kinematics, is this equation as follows. So it's V final equals V initial plus AT. Now, each of those variables have a specific meaning. So VF, that goes together. So the F is a subscript of V. So that means final velocity. Same thing goes with the I. The I is a subscript of V, and that stands for initial velocity. A stands for acceleration, and T stands for time. So it's the final velocity equals the initial velocity plus the acceleration times the time. So there's no multiplication symbol between A and T, but whenever that is the case, it's safe to assume that those two variables are multiplied by each other. All right? Does that make sense so far? Good. So now what I'm going to do with this literal equation is I'm actually going to solve for A step by step. So the first thing I'm going to do is now, like before I get going, there's many ways to solve this algebraically. All right. So the way I'm doing it isn't the only correct way, but it's the way I'm going to show you. All right. So you have VI, right? I always think about this VI is in the way of the acceleration times the time. Now, AT, that's what I want to get by itself. So what I'm going to do is I'm going to subtract VI to both sides. Okay? Now what will happen is the VI will cancel it out over here, and then now our equation looks like this. So we have V final minus V initial is equal to AT. So I subtracted VI to both sides, and now this is what we have. Now the next thing I want to do is I want to divide T to both sides because I'm trying to solve for A. All right, I'm going to try to solve for the acceleration. So now the T cancels out, right? And then I have divide by T over here as well. So whatever you do to the right side, you have to do to the left side. All right, so keep in mind, whenever you have two variables added or subtracted on the numerator, you have to divide the entire, that part of the equation, the whole thing needs to be divided by T. So T has to be in the denominator of both of those at the same time. Okay, now we are left with our final equation, which is V final minus V initial divided by time is equal to A. And it could also be written like this. A equals V final minus V initial divided by time. All right? So keep in mind, VF and VI, those stand for final velocity and initial velocity. Okay? Hope that helps. Thanks.